Have you ever wondered how to shift the entire balance of power across a continent using a single man-made megastructure? $85 billion. This is not a standard maritime infrastructure project. It is an impenetrable economic fortress. The mechanical objective is to forge a monolithic chain of artificial islands, an enclosed logistics corridor today. Looking from above, the entire island installation operates like a giant mechanical entity, functioning without rest. But to achieve this monumental, futuristic achievement, the construction process had to overcome the shelf limits. Each sector and mechanical joint had to undergo a strict manufacturing chain deep within the Caspian Sea floor now. Look at this scale. Millions of tons of materials have been stamped into shape to turn a blueprint into real steel. An isolated, self-sustaining fortress in terms of energy and logistics, ready to reshape the map of Eurasia. To maintain operations for this super fortress, an independent power supply network has been integrated here now. This is the definitive answer from the Alliance, a heavy industrial marvel defying all encirclement and sanctions. To construct this super island, the first phase required handling a dangerous layer of water-saturated liquid mud. Engineering crews were forced to drive high-strength steel cofferdams to isolate the space from currents safely. Each large-diameter carbon steel tube pile was driven deep into the hard shale bed using hydraulic pressure systems. Each foundation joint must achieve maximum mechanical rigidity to eliminate sinking caused by bending stress lines. Millions of cubic meters of ultra-high-performance sulfate-resistant concrete are continuously pumped forward. With underwater foundations solidified, the line scales up immediately to the erection of perimeter barriers. This requires a continuous logistical supply chain, bringing in thousands of interlocking anti-corrosive blocks. Watch the coordinated mechanics. Synchronized heavy gantry cranes lifting and aligning structural modules today. The assembly chain is fully automated, utilizing precise laser guidance networks that cut through thick sea mist. To withstand bending stress from maritime seismic shifts, the outer ring is reinforced with high-tension cables. Simultaneously, specialized industrial crews work hard in perfect sync on the expanding structural seawall now. Every single cable is locked into place under physical pressure, creating an adaptive tension matrix perfectly. Step by step, the outer perimeter transforms into an impenetrable defense shield, isolating the lagoon completely. Behind this secure maritime wall, massive industrial dredging fleets begin pumping high-density structural sand.
Welcome back to the Evening Update. We begin tonight with the latest on the proposed legislative changes set to impact the tech industry.
The volume of dry land expands exponentially every minute, rising cleanly from the dark green waves under daylight. Giant intelligent compactors, operating on automated tracks, roll across the new landmass to densify layers. The compression force is so immense it instantly stabilizes the land, creating a perfectly flat ground platform. Meticulous quality control teams monitor the stabilization via deep sonar arrays and ground radar units safely. With the new landmass permanently verified, the foundation is officially set for the installation of core systems. With the solid ground fully certified, the structural timeline shifts immediately to the fuel routing networks. This stage requires the deployment of automated trench crawlers that carve precision channels across concrete. Giant mechanical cranes now lower massive double-walled alloy storage tanks into the engineered ground safely. Every storage cell is systematically anchored onto reinforced concrete pads to eliminate any buoyancy shifts now. The fluid routing line scales up as robotic pipe rigs align anti-corrosive transport tubes with accuracy today. Watch the seamless mechanical flow. Automated laser welding systems circle each pipe seam under inert gas shielding. To prevent hidden structural defects, digital X-ray crawler robots run internally through the pipe layout now. The network is then wrapped in multiple layers of advanced polymer thermal insulation against freezing winter. Simultaneously, specialized technicians install smart electronic shutoff valves with optical sensors here. These autonomous digital control valves act as the neural network capable of isolating specific fuel sectors. Following pipe integration, heavy industrial dump trucks pour a specialized high-density backfill matrix here. Massive vibrating structural plates pass over the backfill layers repeatedly, locking the network into blocks. The production chain moves above ground, where massive concrete pump booms begin pouring the thick primary slab. Teams of skilled workers guide the continuous distribution of concrete, ensuring a flawless surface finish now. As the concrete sets, the underground fluid matrix is integrated, creating a hidden spine for the fortress. With the subterranean spine secured, the industrial line scales upward to erect heavy steel framing systems. Colossal automated CNC milling machines on site cut through thick alloy plates, preparing vertical columns now. Watch the precision assembly flow as heavy crawler transporters move these massive pillars into exact position. Each structural pillar is anchored using extreme torque units, locking the alloy feet into the slab deck below. The rigging line expands as massive overhead gantry cranes hoist crossbeams, spanning hundreds of meters safely. Automated magnetic clamping systems lock the beams instantly, holding the heavy structures perfectly rigid now. Multi-jointed robotic welding gantries track along joints, fusing structural steel with precise plasma arcs. This creates an unyielding overhead grid system, optimized to carry the immense weight of heavy harbor cranes. Simultaneously, specialized industrial crews clad in uniform gear begin installing heavy-duty steel tracks. Every rail segment is aligned with absolute precision using high-frequency digital scanning arrays here today. The assembly process moves to the installation of smart power bus bars running parallel to the crane tracks. Heavy-duty automated spooling units lay down high-voltage armored copper cables into deep channels safely now. With the structural framing and power lines integrated, teams prepare for primary crane assembly operations. Giant hydraulic lift towers are erected on the dock, ready to hoist the main trolley cabins into place quickly. The entire structural framework stands complete, a monument of modern engineering rising high above water lanes. With the steel framing completed, the production line moves to the integration of ship handling lift networks. Colossal hydraulic winches, built with polished iron drums, are aligned across the deck to manage platforms. Watch the seamless mechanical flow as heavy steel hoisting ropes are wound onto drums by synchronized motors. The assembly chain expands as technical crews mount high-torque gearboxes onto the solid concrete foundations. Each gearbox unit is anchored using pneumatic impact tools, locking casings with zero margin for error safely. The process moves to the installation of automated mooring winches distributed along canal banks right now. Smart electronic control panels featuring digital displays are fitted to manage real-time tension statistics.
Good evening. The Prime Minister has just announced a significant shift in economic strategy, prompting immediate reaction across the markets.
Simultaneously, specialized industrial teams begin assembling the hydraulic power units for canal lock gates. High-pressure steel fluid lines are run through tunnels, connecting primary pumps to massive lock cylinders. The assembly process transitions into the mounting of the heavy lock gate hinges forged from solid alloy bars. Giant mobile crane systems hoist the massive gates into position, aligning edges within a millimeter scale. Automated plasma cutting rigs slice through temporary bracing, releasing gates into operating tracks cleanly. With the mechanical lock gates integrated, technical crews initiate a complete dry run testing sequence now. The entire canal lift infrastructure stands ready, a mechanical marvel poised to control maritime flows here. With canal gate mechanics certified, the flow moves instantly to deployment of cargo container storage yards. This stage requires installing networks of automated magnetic tracks embedded directly into concrete floors. Watch the coordinated process as heavy steel rail lines, laser straight, are anchored across storage zones. The assembly chain scales up as colossal rail gantry cranes are assembled piece by piece on the track lines. Each crane carriage is secured with extreme hydraulic bolts, locking structures permanently into rail layouts. The mechanical line expands as technicians install advanced optical sensor arrays along the top structural beams. These autonomous laser eyes calibrate instantly, ready to map out container coordinates without human errors. Simultaneously, specialized industrial teams begin wiring high-voltage ground slots for the driverless trucks. Thick, armored copper power bars are run into protective concrete trenches across the entire yard grid area. The integration process moves to the placement of primary digital control towers flanking the active zones. Giant high-contrast LED status displays are mounted onto tower frames, illuminating the industrial site clearly. Following tower integration, specialized automated transport trucks are rolled onto magnetic tracks safely. The vehicles move smoothly in perfect lines, their onboard sensors communicating directly with the command grid. Teams of uniformed technicians conduct a complete stress test, verifying electrical load metrics across lanes. The cargo storage infrastructure stands complete, a hyper-modern logistics hive optimized for rapid distribution. With the storage infrastructure operational, the line branches into the installation of desalination systems. Massive multi-stage flash distillation chambers, forged from titanium, are positioned along the coastlines. Heavy hydraulic crawlers slide these giant processing blocks into place, locking them onto dampening pads. The line expands as heavy titanium alloy pipes, designed for saltwater, are coupled by robotic crane rigs. Watch the seamless automated assembly. Computer-guided orbital arc welders glide around each pipe seam now. To guarantee complete hermetic sealing against corrosive pressure, ultrasound scanners trace the weld seams. The processing network scales up as technicians install high-pressure centrifugal pumps in bright yellow paint. These colossal intake pumps pull seawater directly from the deep ocean, pushing it through filtration layers. Simultaneously, specialized industrial teams mount advanced electronic flow manifolds along the metal racks. Every control manifold is wrapped in high-visibility casings, packed with fiber optic sensor pods today. The assembly chain transitions above ground, where cranes install chemical mineralizer composite silos safely. Giant mechanical mixers inside the silos are calibrated using high-torque hydraulic automated drive units. Following silo integration, crews lay down heavy steel-reinforced polymer sheets to seal the zone cleanly. Massive automated power distribution boards are linked directly, lighting up the technical corridors forward. The entire fluid processing plant stands complete, a chemical marvel designed to supply millions of liters. With fluid processing ecosystems synchronized, the manufacturing line transitions to electrical network nodes. Colossal solid-state transformer blocks, insulated with polymers, are aligned within the central substation. Watch the precision workflow as heavy gantry cranes lower these electrical cores into concrete vaults deep. The power line expands as automated mechanical arm lifters route thick copper bus bars through tunnel layouts. Every electrical junction is systematically locked down using pneumatic calibration wrenches for safety goals.
Good evening. We begin tonight with the breaking news from Westminster, where the Prime Minister has just announced a snap general election for June 15th.
Massive computerized hydraulic rams apply thousands of tons of dynamic force to simulate storm waves now. Every movement is tracked via fiber strain sensor networks, feeding structural metrics into computing hubs. Simultaneously, specialized industrial crews begin connecting high-frequency radar defense tower arrays. Thick armored data conduits are integrated along hulls, connecting the active arrays to command systems. The assembly chain moves to the deployment of automated backup energy banks lined up in concrete vaults. Massive lithium-ion storage blocks, painted in brilliant yellow, are locked into their charging dock units. Following battery integration, specialized technicians initiate a full-scale grid-switching dry run process. Vibrant glowing status displays and telemetry interfaces illuminate rooms as energy matrices stabilize here. The power distribution and testing sequence concludes successfully, providing an unyielding energy spine block. With the energy spine synchronized, the final assembly line initiates integration of logistics terminal hubs. This final phase requires the systematic mounting of overhead sorting conveyor networks across main halls. Watch the seamless mechanical sequence as automated hydraulic lifters elevate track structures into ceilings. Each track segment is locked into the overhead alloy frames using high-torque pneumatic bolts precisely now. The mechanical line expands as technical crews deploy smart cargo scanning gates equipped with laser rings. These autonomous digital checkpoints calibrate instantly, ready to process thousands of cargo packages. Simultaneously, industrial installation teams begin lining up rows of terminal seating benches in blue color. The interior layout pops with deep, saturated colors as bright maintenance units are positioned near lanes. The process moves to the activation of the primary digital network across the centralized transit halls. Giant high-contrast LED electronic boards are mounted onto walls, illuminating the space with clear data. Following display integration, autonomous luggage handling rovers are rolled onto floors for verification. The automated rovers glide in perfect synchronization, communicating with the central hub via fiber lines. Teams of uniform industrial workers in identical gear conduct final structural checks on the exit gates. Every mechanical barrier cycles open smoothly under natural daylight streaming through architectural glass domes. The final testing phase scales up as a full-scale simulated baggage routing dry run is executed right now. The entire interior ecosystem of the logistics terminal activates flawlessly, a monument of engineering art. Looking outward from terminal bays, the completed artificial island fortress stands fully operational today. A triumphant, overscale industrial masterpiece born from a strategic alliance, redefining the landscape. The massive artificial fortress operates continuously in harmony, defying all external economic pressures. This documentary is for education only, based on real sources. Theories are not facts.